Hey everyone, so today we'll look at problem number 102, which is the binary tree level order traversal problem. As you can see, this is a medium problem. So tree programs are always asked in Amazon interviews, and this is a well-known problem which is asked in Amazon interviews. So let's read the description. So given a binary tree, return the level order traversal of its nodes values from left to right, level by level. For example, given binary tree 3, 9, 20, null, null, 15 and 7. So you have given a binary tree, so 3, 9, 20, 15 and 7, right? 9's left and right are null, so that is marked by here. So return its level order traversal as, you see, root as at level 0, and so you've got just 3. At level 1, which is 9, you have got 9 and 20, so that is 9 and 20 is returned. And then at level 2, you've got 15 and 7, so 15 and 7 is returned. Okay, now let's see how can we solve this problem intuitively. And any traversal, right, be it level order traversal or pre-order or post-order or in order. So we will be, it's good to adopt a recursive solution. Now, let's say we are starting from the root, right? We have to start from the root because root's value is returned first. So root is at level 0. So let's say we are initializing level 0 and calling a recursive function with node with a root, right? So at level 0 we see 3 is the only value which is present, right? And then we can proceed down, which is left, and then we can proceed right. Now, under what conditions can we add? We need to identify, right? We need to identify at what conditions we should be adding values to the same list. So for example, at node 3, right, at root 3 value, we will be adding a new list, right, at level, because that is a new level. But if you look at 9 and 20, at 9 you will be adding a new list, but then at 20 you should not be adding a new list, you should be adding 20 to the existing list at level 1. Same thing in the case of 15 and 7. So suppose if 9 does have values, right? In those cases, 9 will be having two values. So which means like to those two already added values list, we should be basically adding 15 and 7. Okay. So now let's say I'm calling calling 3 with 0. Right. So initially what you can say, you can initialize, we are supposed to return a list of integers. Let's say we have initialized it with a empty array list. So the size will be 0, right? When size is equal to 0, let's say we are instantiating, not instantiating, we're adding another list, because at every level we need to return a list of integers. So let's say we are adding a list at 0. Okay, so to this list we will be adding 3. Okay, now let's call this recursive function. So 3 has a left, so which means we will be calling this recursive function, let's say 9, with 9, and then level will be 1, right? Now at 9 we see this is a new level, right? 1 is a new level. So in this case the size of the list that we have got so far is actually 1. So which means we can add a new list, right? So at level 1, we'll go ahead and add 9. Okay, and 9 does not have a left and right, so the recursive function will return, right? And then intuitively what you will do, at 20 you will go, right? And so at 20 you see that the size of the list is actually 1, right? And to this list, one's list, you should basically add 20. So what you can do is, if there is a list, right, if the size of the list, if it is equal to the level, which means we're encountering the level for the first time, right? So if for example at level 0 the size of the list was 0, right? So we added a new list and we added 3. Now size has become 1. Right, so when we went to 9, we saw that the size of the list is actually 1. So which means, you have to open up a new level. So we added another list. Okay, and so similarly, like so now 9's recursion has gone, right? It has ended. Now let's come to 20, right? So 20 will be called with 1 because its level is 1, and so we added 20, and so 20 is uh, 15. The level, I mean the left is actually will be called with 15 comma 2, right? Now the size is actually 2, right? So you have got a zeroth list and you've got a ones list. And at level 2, the size of the list is actually 2, so which means you're encountering a new level. So at level 2, we will be adding 15. Okay, and so 15 does not have a left and right, so this recursion will come back. Now we will be exploring the right hand side, which will be called with 7 comma 2, right? It's 7 is at level 2. Right. Now if we see that the size of the list is already 2, which means we have already encountered a node in that level. So which means the existing level 2 we should be adding 7, and 7 does not have a left and right, so the recursion ends here. Okay, so this is a very simple recursive solution where we start with the levels. We are basically processing levels. Okay, so let's quickly initialize and code this problem. Okay, so we will be returning a list of integers. Okay, and this result, let's initialize it with an array list. Okay, and this array list is what we will be returning in this program. So return result. Okay, now we need to have if root is equal to null. Let's say we'll handle the null case. Root is equal to null. We'll just return this empty array list, right? We have to return this. So we'll return error of result. Okay, otherwise let's have a recursive function. I'm going to call it as level order recursive. Okay, so to this we'll say root and we'll call it with 0, which is the level. Okay, I'm just going to copy this. So now let this be private, and we'll call level order recursive. So I'm going to say tree node of node, and this will be your level. Okay, now let's consider this example. So initially level will be 0, right? So and the list is empty, so we need to add a list at 0 and add 3, right? So basically if result dot size, this is equal to level, which means we're encountering this level for the first time, so which means in result we will be adding a new array list of integers. Okay, now we have got this list. So to this list, result dot get of this level at level 0, we will be adding node's value. Okay, now we have to proceed left and right. We've added this one, so this is the only node at this level. So if nodes left, if this is not equal to null, then we will call this function recursive function with its left node dot left and then level plus 1, because left and right nodes are at level plus 1 for this node. If root dot right not equal to null, same thing we will do. We will recursively call this function at the right with the current level plus 1. Okay, so now let's walk through this example. So at 3, right, so we let's say result dot size is equal to level, so 0 is equal to 0, which means we've added a new array list, and then to this level list, so which is at 0th levels list, we are adding nodes value, so we have added 3. Okay, now 3 has a left, so we will call level order recursive with 9 comma 1, right, the current level plus 1. Now we will be entering this recursive function. So we see that result.size is actually 1. 1 is equal to 1. So which means we need to add a new list. So to this new list, we will be adding 9. Okay, and 9 does not have a left and 9 does not have a right, so both of these recursive calls will not get called for 9. So which means we will go ahead and call level order traversal for this recursive function for 20 with 1, right? And we see the size of the list. We've got one list at 0 and we've got one list at 9. So the size of the list is actually 2, and 2 is not equal to 1, right? Which means we need to get the level, the current level, which is 1, and to this level we will be adding 20. Yeah, and 20 has a left, so which means we need to call 15, so which is level order, and 15 with 2, right? And now we see that result.size is 2 and that is equal to the level, which means we need to open up another new level. So to this we will be adding 15. Now 15 does not have a left and right, so we will come out of this and then we will call level order traversal for 7, right? So level order traversal for 7 comma 2, and we see that it has already, this condition will not hold true. We cannot add a new array list, so which means to the existing level we need to add this, right? So this level we will add 7, and then 7 does not have a left and right, so which means we have come out of this recursion. So now we have got 3. We have got a list at level 0 and we've got a list at level 1 and we've got a list at level 2, so that is the answer. Okay, so this is a simple recursive solution. Okay, so you basically, if root is null, you return the result and then call this level recursive function with root and 0. And if result.size is equal to level, which means we are encountering this level for the first time, so we will add a new array list, because every level has a list of integers which collects the nodes values at each level. And to this list at this particular level we will be adding nodes value, and if it has a left then we will recursively call this function for the left, and if it has a right then we will recursively call this function for the right hand side. And finally, by the end of this recursive function, you would have filled the result, which will be returned. Now, when you consider the space complexities of any level order, any traversal, be it level order or post order or pre-order, the time complexity is going to be O of n, because we will be navigating to every node in the binary tree, right? And what about the space complexity? So although you see that this is recursion, so which means like it will inherently make use of the recursive stack, so at the maximum it is going to be O of n again, right? So that's it. Let's run this code. It's accepted. Let's submit this code, and it's a successful submission. I hope it was clear. Bye guys.